Hi there, this is Physics, the chapter on transfer of thermal energy. This video is the first in the series that will deal with the physics idea of how thermal energy is moved from one place to another. For lesson 1, we will deal with 3 key concepts. These are thermal energy, temperature, and thermal equilibrium. Before we move on, I would like all of you to keep something in mind. The kinetic theory of particles from previous lessons. Recall that this theory states that particles are always in constant motion, and furthermore, recall how the particles are arranged in solid, liquid, and gas states. And when I say this, I hope phrases like vibrate about fixed positions, slides around, closely packed, far apart comes back to mind. What you have learned and understood from that chapter will provide the base from which you will understand the ideas of this chapter. So, let us first see how this chapter is relevant to us. As I have said, physics is the science of what we experience every day around us. So, do we encounter transfer of thermal energy in our daily lives? You bet we do, right? One good example is cooking. Let me help bring you back to your first cooking experience. For many of you, that will be the first cooking lesson during Sec 1 home economics lessons. What do you cook up that day? Can you remember? Is it pasta? Well, so for the purpose of this video, let us just imagine that you're frying some French fries during that lesson. During cooking, you know that heat comes from the stove top and somehow move to the pot and through the bottom of the pot to the oil at the bottom of the pot. And from there on to all parts of the oil inside the pot and finally to the fries. You would probably have felt the heat from the cook stove over here and or from the oil traveling to your hand. So how this heat moves from one place to another is the main lesson for this chapter. So before I move further, let us revisit the learning outcomes for this particular video through these questions. Now, having gone through this particular video, you should be able to answer these 3 key questions. What is thermal energy? How heat or thermal energy moves? And what is thermal equilibrium? We will discuss conduction, convection, and radiation in the next few videos, right? Now, we will start off by understanding the difference between temperature and thermal energy. Well, what is temperature? Temperature is a measure of how hot or cold an object is, and it is usually measured in degrees Celsius or in kelvins, capital K. Recall that the SI unit of temperature is actually the Kelvin, but many of us we are more comfortable with dealing with temperature in degrees Celsius. And so from this point onward, when we are discussing further examples of heat transfer, I will always refer to temperature in degrees Celsius rather than in kelvins. Now, what is thermal energy? Thermal energy is an amount, or rather the amount of heat an object contains. It is simply another form of energy, and we measure this thermal energy in joules. Now, many students often confuse temperature with energy. They always ask, are they the same thing, despite learning what they mean? Well, certainly they are not. Temperature is not the same as thermal energy. Okay? How they are related is this. An object that is hot have more thermal energy or heat compared to an object that is cooler. So naturally, this also means that thermal energy will flow from a region of higher temperature to a region of lower temperature. It makes sense, right? Imagine putting some ice cubes into hot tea. Heat from the hot tea will move into ice, which is of course cooler. You know that this happens, and when this happens, this causes the ice to melt and result in the tea becoming cooler. This goes on until the tea and melted ice are at the same temperature. When both of these has reached the same temperature, we call this condition thermal equilibrium. Right, perhaps the example of tea and ice may be a little bit confusing, so let us revisit thermal equilibrium again. Now, I would like you to imagine that there are 2 solid objects placed side by side. Of course, this diagram does not seem to show that, but I would like you to imagine that both this object A and B, they are touching each other and placed side by side. Okay. Now, let's say object A is at 60 degrees Celsius, while object B is at 20 degrees Celsius. Since object A is hotter, we know that heat will be moving from A to B. Well, if that's the case, the temperature of A will actually drop with the continuous transfer of energy to B, while the temperature of B will actually rise. This will continue until the temperature of both A and B has become the same, at 40 degrees Celsius. So when both A and B has reached the same temperature, we say that both A and B has reached thermal equilibrium. When this has happened, effectively, there is no more transfer of heat between A and B. We say that there is then no net transfer of thermal energy between A and B. Now, coming back to heat transfer, you may right now know that there are three modes or methods of heat transfer. The first is conduction, convection, and radiation. Okay. Now, usually it's interesting to note that conduction, heat transfer happens in things like this, in solids, while convection and radiation, heat transfer seems to travel between through gas itself. Okay. So in the next three videos, we will discuss this method separately. Now, before we end this video, let us do a quick recap of what we have learned. All right. The first question was this: what is thermal energy? Well, thermal energy is a form of energy also known as heat. It is not the same thing as temperature, and this is something that you will have to remember. How does heat move? Well, heat or thermal energy moves from a hotter to a colder place. And finally, what is thermal equilibrium? It is a condition where all objects have achieved the same temperature. Thank you.